Okay, should be recording now. Okay, so this is the first example. So we have the integral from 0 to 1 of x e to the x. We do everything as we would for an indefinite integral, but then we've got this extra step here. So we've got extra step here where we need to evaluate at the upper bound and at the lower bound. Okay, because we've got a definite integral, so we need to do this evaluation. Okay, but everything else is exactly the same. Any questions about this one? Okay, so not too bad. Just one more extra step that you need to add onto the list. Okay, let's try example number 2. So we have the integral from 1 to 2, x natural log of x dx. Okay, again, very similar to something we did last time, but now we've got the bounds that we need to worry about in that extra step. So we let u be equal to x because that is easier. Forgot to write here. U is ln x because that is easy to differentiate. Integrating the natural log of x, that's difficult. Differentiating the natural log of x, that's a lot easier. So that's what we choose u to be. Okay, then of course dv will be everything else. So dv will then be x dx. Okay, that's the leftover part there. So now we need to differentiate u and we need to integrate dv. So du will be 1 over x dx. And integrate, v is going to be 1/2 x squared. Okay, so we've got du, we've got v, and we've got u and dv. So what we need to do now is substitute into the formula. So the integral from 1 to 2 of x natural log of x dx will be u times v evaluated at the bounds. So it will be 1/2 x squared natural log of x evaluated from 1 to 2 minus the integral from 1 to 2 of v du. So that will be 1/2 x squared times 1 over x dx. Okay, so I've got my u v and my v du. Okay, so I've substituted everything in and remember to include the bounds. So what do we get now? So we're going to have 1/2 x squared natural log of x going from 1 to 2 minus 1/2 integral x squared over x. That's just going to be x from 1 to 2. So we're going to end up with 1/2 x squared natural log of x from 1 to 2 minus 1/4 x squared from 1 to 2. Okay, because you add 1 to the exponent to make it 2, divide, we get half times half, which is a quarter. Okay, so now we need to evaluate at the bounds. So the first bracket, we're going to get 1/2 2 squared natural log of 2 minus 1/2 1 squared natural log of 1. That's our first bracket, minus the second bracket is going to be 1/4 2 squared minus 1/4 1 squared. Okay, so that's our 2 brackets taken care of. Now just quickly, natural log of 1, that is 0. So we can just get rid of that. So that one we can just ignore. Okay, so what's left? We're going to have 1/2 of 4, that's going to be 2. So 2 natural log of 2 minus 1/4 of 2 squared. That's 1/4 of 4, which is just 1. And then plus 1/4 times 1 squared, that's just going to be a quarter. Okay, so we're going to end up with 2 natural log of 2. minus 1 plus a quarter, we're left with minus 3/4. Okay, so then that's the final answer for this problem. So again, it's very similar to what we did before. All your steps are exactly the same. It's just at this final step here, you need to evaluate at the upper bound and the lower bound. Okay, so remember to do your evaluation. Okay, but everything else, same as we did last time. Any questions so far? Okay, cool. Let's take a look at the last problem for today, and then I'll put up the homework exercises. Okay, and as always, these homework exercises, they will be bonus marks. And since next week you're writing the test, I think it's next week, let me just check here. Yeah, next week, 6th, you're writing your test. These bonus marks will then count towards your test because you're not writing a quiz. Okay, so last problem, number 3, we have the integral from 0 to pi over 2 of x sine squared of x dx. Okay, now we need to pick something that we can differentiate easily, something that we can integrate easily. Now differentiating x, we can do that. So let's say u is equal to x, and let's say dv is equal to sine squared of x dx. Okay, so let's see how this works out. So we need to differentiate u. So du is going to be dx. That's pretty easy. Now we need to integrate dv. So integrate that, integrate that. We're going to have v is the integral of sine squared x. Okay, so this looks pretty difficult, integrating sine squared. But remember, there is that half angle identity for sine squared. So we can write this as the integral of 1/2 of 1 minus cos 2x. Okay, if this was cos squared, then we would have a plus. But since this is sine squared, it's going to be a minus. Yeah, that's the difference between the two things. Okay, so this is easy enough to integrate now. So we have v is equal to 1/2. Integrating this, we're going to have x minus 1/2 sine 2x. Okay, so that is our v once we've integrated this. So we've got du, we've got v, that's all we need to substitute. So the integral from 0 to pi over 2 of x sine squared x dx is going to be u times v. Okay, so it's going to be x times 1/2 x minus 1/2 sine 2x from 0 to pi over 2. Okay, so that's our u times v minus the integral from 0 to pi over 2 v du. Okay, but du is just dx, so that's easy enough to do. And then we have 1/2 x minus 1/2 sine 2x dx. Okay, so that's everything there. Now we just need to do the evaluation of the first bracket and then integrate this last term over here. Okay, so let's just simplify this. We're going to have 1/2 x squared minus 1/4 x sine 2x from 0 to pi over 2 minus 1/2 integral from 0 to pi over 2 x minus 1/2 sine 2x. Okay, that integral is pretty easy to do. So we're going to have 1/2 x squared minus 1/4 x sine 2x from 0 to pi over 2 minus 1/2. And then we're going to get 1/2 x squared. Then we're going to have plus 1/4 cos 2x. Okay, the sign becomes a minus cosine. And then we have the factor of 1/2 from 0 to pi over 2. Okay, good. So everything's integrated now. We just need to evaluate all of this at the upper bound and then at the lower bound. So let's deal with the first bracket. We're going to have 1/2 pi over 2 squared minus 1/4 pi over 2 again, and then sine of pi. Okay, so that's because sine of 2 times pi over 2 is sine of pi. And then, yeah, there we go. So that's how it simplifies there. Next, if we substitute 0, everything becomes 0. So we don't need to worry about that. Minus 1/2. Now we're dealing with the second bracket. We have to put in pi over 2. So we're going to have 1/2 pi over 2 squared. Pi over 2 squared plus 1/4 cos of pi. Okay, again, because the 2x becomes 2 times pi over 2, which is just going to be pi. Okay, so that's at the upper bound, and at the lower bound, we're going to have minus 1/2 of 0 squared is 0, but then 1/4 of cos of 0 is going to be 1/4. Okay, so don't forget that cos of 0 is 1. You can't just ignore that. Okay, anything that we can simplify here? Sine of pi is going to be 0. So this term, that can go away. Cos of pi is going to be minus 1. So that simplifies nicely. So we end up with 1/2 of pi over 2 squared. That's going to be pi squared over 4, pi squared over 8. That's from this term. The other term that went away. Then lastly, we have pi squared over 4, but then half that, pi squared over 8, half that again, pi squared over 16. That is this term. Then 1/4 of cos pi is minus 1. So we have minus 1/4 times minus 1/2. That's going to be plus 1 over 8. And lastly, minus 1/2 times minus 1/4. That is another plus 1 over 8. Okay, that should be everything there. Okay, next we need to find a common denominator here. So this is going to be 2 pi squared minus pi squared over 16, and then plus 2 over 8, we can write that as 1/4. So this is going to be pi squared over 16 plus 1/4. Okay, hopefully I haven't made any multiplication mistakes there. Okay, so the main part is just getting this integration done. Okay, once you get the integrals done, then the most difficult part is over. And then just remember for the last step is to substitute your upper bound and lower bound. Okay, and then the rest is just working with fractions and adding and stuff. Okay, that's not too bad. Okay, but this top part, this is the most important part here. So that's where all the marks are going to be. Okay, in this top part. Your final answer, that's just like 1 mark. Okay, but I want to see that you can do the integration. That's more important. Okay, are there any questions on this? Okay, so not too bad, hey? Okay, let's have a look at the homework exercises. Wait, got a question here. Please repeat this question as well. I think we're actually going to be running out of time soon. So how about I rewrite the solution with some explanation from the second step, okay? Let's take a look here. Which second step? This part over here. That part, okay, sure. So the second step here is exactly what we did last time. It was the integral of u dv, but now the bounds are from 0 to pi over 2. So this is equal to u times v, evaluated from 0 to pi over 2. That's this part here. Minus the integral from 0 to pi over 2 of v du. That's this part over here. Okay, so that's that part there. This first bracket, we can just leave that alone. We can save that for later to evaluate. This integral, we need to evaluate. So the integral of x is going to be 1/2 x squared. The integral of minus 1/2 sine 2x, we need to take a factor of half because we have to divide by 2. So we get an extra factor of half. And then the integral of sine is minus cosine. So the minus and the minus make a plus. So we end up with plus 1/4 cos 2x. So that's integrating that second part. So 1 and 2 becomes 1 and 2. And then we need to then evaluate at the bounds. Okay. So for the first part, we substitute in pi over 2. Okay, and then we simplify that. If we substitute 0, we're going to get 0 minus 0. So that's just 0. So we don't need to write that. And then for the second bracket, we substitute pi over 2 over there and over there. And then if we substitute 0, then cos of 0 is 1. But we've still got that quarter in front, so we get minus 1/4. Okay. Then sine of pi is 0, so all of that goes to 0. Cos of pi is minus 1. Okay. So then we end up with the following here. Then we just simplify, add the fractions together. We add the fractions together, and then we get our final answer. Okay, but I'll post this again on the WhatsApp group with some more explanations. Okay, but that's the idea. Okay, is that all right? Okay, you following along with that? Yeah, okay, awesome. Okay, so let's take a look at these homework problems for today. Sorry. Okay, so we've got a couple homework problems for today. Same rules as always. You have until 5 to post the solutions, and then you'll get bonus marks for the test coming up. Okay, so normally the bonus marks are for the quizzes, but since you're writing a test, I will put the bonus marks for that. Okay, so we've got the integral from 0 to 1 of x tan inverse of x dx. That's question 1. Question 2, we have the integral of x sec squared of x dx. Okay, let me just check the bounds for this one. Sorry, just give me a second, please. Okay, yeah, so it's from 0 to pi over 4. That's for that one. And then problem number 3. We have the integral from 0 to 2 of x cubed e to the x squared dx. Okay, so we want to solve these. And then they are all worth 1 bonus mark. Okay, so you're going to have to do integration by parts, but this time we have the bounds to also worry about. Okay, so have a go at these 3. And if you post the correct solution, I'll give you your bonus marks for the test. And then whatever's left over, I will post the solutions at 5. Okay. Okay, just quickly about the test. I've already posted the scope for the test. So it's going to be just a few questions. Area between curves. So you're going to get a question on that. You're going to get a volume question. So it might be a disk method, washer method, or shell method. It's going to be one of those. An integration by parts question. So something like this, what we've been doing this week. And lastly, a question on finding the average value of a function. Okay, but we will cover that tomorrow. Okay, and just as a warning, this integration by parts, it may appear in other questions in the test as well. Okay, so you're finding the area between curves. The integral over there might need integration by parts, might need u substitution. Okay, so you need to figure that out. Or finding the average value of a function, you might need to use u substitution, you might need to use integration by parts. Okay, so there's going to be a question by itself on integration by parts, but they could also appear in the other questions as well. Okay, so please have a look out for that. Okay, are there any questions about the setting out for the test? Okay, no questions there. And it will be the same as we did with the formative test, so a formative quiz. So the test questions will be on Learn 2022 in the form of a quiz like we had last time. So you attempt the quiz, you can see all the questions. You're going to have to write out all your solutions on paper, scan them, and then submit in the submission form. Okay, so exactly the same as we had last time. Okay, and then it will be out of 45, same as before. You're going to have a bonus question out of 5. Okay, so you can get an extra 5 marks there in case you make some silly mistake somewhere else. So you could still get 100% even if you mess up somewhere. Okay, that will be 5 marks extra. Okay, any questions about that? Okay, so tomorrow we're going to finish off with the finding the average value of a function, and then Monday and Tuesday we do test revision. You write on Wednesday, and then we start the final chapters on the Thursday. Okay, but we will get to that next week. Okay, as always, if you do have any questions, let me know via email or on the WhatsApp group. Okay, and good luck with these homework problems. Okay, bye everyone.
Sir,
Yeah.
would you please upload the video on Learn Early after the class?
Yeah, so uploading videos takes a bit of time because it's a large file, but I normally upload them straight after the lecture. So it should be available pretty soon.
Oh,
okay, any other questions?
Thank you.
Sure. Anything else? Okay, I'll see you tomorrow for the last chapter. Bye, everyone.